Today we are going to begin a new topic, that is gravitation. What is gravitation? See, Newton found that if you have two masses, say m1 and m2, say separated at a distance of r, then m1 and m2 exert force on each other, and that is called gravitational force. m1 and m2, two body having masses m1 and m2 and separated by a distance r, then they are exerting force on each other, and that force is force between, and we call it gravitational force. Basically we call it gravitational force. Gravitational force between m1 and m2, they are given by F equals to, and this force between these two masses, they are proportional to, let me write like this, this force is proportional to product of masses of two bodies, that is m1 into m2, and he found it is inversely proportional to r square, right? So if I write it mathematically, then this is proportional to, in fact, m1 m2 by r square. And to remove this proportionality constant, I'll put one constant, and that constant is called universal constant of gravitation. G is universal constant of gravitation or gravitational constant. So this F, the force between two bodies, can be written as G m1 m2 by r square, where G is called universal constant or universal constant of gravitation, right? Universal constant of gravitation. Its value has been found to be 6.67 into 10 to the power minus 11. And what would be unit? You can see unit would be G would be F into r square upon m1 m2. So the dimension is, this is F is Newton, this is meter square, and this is kg square. So it will be Newton meter square kg square, right? So you can see that this constant is very small. You can see that this constant is very small. So this force would be considerable only when m1 and m2 is very large. This force will be considerable, or it will be in observable range, or it will be measurable only when, I am not saying measurable, I can say it is considerable. Even a very small force can be measured now. So I can say that this force is considerable only when m1 m2 is very large, or at least one of these will be very large. Either of m1 m2 has to be very large. If both of them are large, then of course F will be very large. But even if one of them is very large means it should be in the range of mass of some celestial bodies. This m1 m2, this G is very small, so m1 m2 should be very large, and this can be very large if both m1 m2 are very large, like say Sun and Earth, or you can have one of the mass is very large, like say Earth and a person lying on the Earth. So Earth is having very large mass, and this person is having very small mass, of course, compared to Earth. So one of the body has to be celestial body. If you want this to be considerable, at least one of the body has to be a celestial body. If you have two people over here, person A and person B on the Earth, then gravitational force between these two people will not be so high. Why? Because G lies in the range of 10 to the power minus 11, and say the weight of mass of this person is 60 kg, and this is 100 kg. So in all it will come as 10 to the power, say at max 4, or distance can be in 1. So it is very, very small, not even observable, not even observable. It's not even in observable range. So in order that gravitational force between two bodies is very high, one of the body must be having very high masses. One of the body must have very high mass. For example, say in case of Earth, you see the mass is very, very high. Mass is very, very high. So that makes the exactly, I don't remember the mass right now, but mass is extremely high, and in that case the gravitational force between Earth and the person lying on the Earth is very large, is considerable, and that is equal to weight of the person. If the mass of this person is say 100 kg, then gravitational force acting on this body, gravitational force exerted by this Earth on this body would be approximately 1000 Newton or 980 Newton. Right? So this is what is called gravitational force. This is gravitational force, and this whole thing is called universal law of gravitation. This is called universal law. What is the law? Law is when you have two bodies having mass m1 m2, then they exert force on each other, and the force, that force is gravitational force, and the gravitational force is depending on product of the mass and inversely proportional to r square, and hence we can write like this. So this is a universal law of gravitation. This is universal law of gravitation, right? So what do we find? We find the magnitude of gravitational force between these two masses, that is equal to g m1 m2 by r square, and direction of gravitational force. See, of course, in any force two things are very important. One is magnitude, other is direction. Direction of gravitational force lies along line joining two bodies. That's about direction. And nature is the gravitational force between two bodies is only attractive. Means m1 m2 will be attracting each other with this force. The nature will be attractive, unlike electrostatic force, which can be repulsive also. This force is very similar to Coulombic force that you study in electrostatics, that is 1 by 4 pi epsilon r, which is constant, q1 q2 by r square. But this force can be repulsive also. If the two charges are like charges, if the two bodies have got same kind of charge, this force will be repulsive also. But in case of gravitational force, it is always attractive. It is always attractive. Since it is always attractive and the force is lying along line joining two bodies, so force on m1 would be lying in this direction and force on m2 will be lying in this direction. Force on m1 will be lying in this direction and force on m2 will be lying in this direction. Alright, it will be lying always along line joining the two bodies. It will be always lying along line joining two bodies. Okay, so this is gravitation. This is all about gravitational force. Let's take some question where we can make use of this gravitational force. Alright, question based on this gravitational force, or I should do in the next video the questions. Okay, thank you very much.